right? We have talked about the array, okay? We have talking about the linked list, okay? We have talking about the stack, okay? Today we're going to talking about another linear data structure, queue, okay? Let me try and find this one, data structure in Python, linear data structure, list, dictionary, tuple, set, right? Array, linked list, stack, queue, yeah. Okay, non-linear data structure, okay. So from the left to the right, okay, we have already learned primitive is type, okay, basic is type, integer, float, string, boolean. And then we are talking about a little bit non-primitive, right? You can also understand it's a complexity data structure, okay? From the left to the right, linear data structure. Linear means it's a list, it's a chain, okay? It's one dimension, okay? It's a linear. We have already learned a list, dictionary, tuple, set, okay? And in this semester, right, we explicitly explained array, okay? Linked list, stack, and today we're going to talking about another one, queue. Okay, queue. Jeffrey, what is a queue?
A queue?
Yeah, just using your daily language to explain
okay,
what is queue.
I guess it's more of a British term, but it basically means like line or order.
Line and order.
Line.
Oh,
like,
line. Yeah, you're right. So queue is a line. Okay. So what kind of scenario in our daily life you have a queue? Can you give me like a example in our realistic life? Jeffrey?
What do you say?
I said, right?
Yeah, my internet connection is not too good, so.
Internet connection.
Yeah, I'm like bad internet connection.
You're running a bad internet connection? Okay. Julian, you give my question. We know Q, right? It's just like a line. So I just want you to give me a example in our realistic life. Like, hey, in what kind of places you are gonna see a Q?
Sir, I can't hear you. The internet connection. Yeah.
It's my side connection problem or you guys side connection problem?
I don't know, but I can't hear you. That's all I know.
Okay, so now let me be closer to the mic, right? I'm asking you, right? We know Q. Q is just like a line, okay? Can you give me a realistic life? Realistic example about Q in our daily life? You get my point?
I don't get.
Okay, anyway. So Q is a structure, okay? We can see normally in our life, like what? Like line up, okay? You go to a supermarket, right? There'll be a queue, or there'll be a line to what? To shopping or to the checkout. Am I right? You cross a bridge, right? Or cross a bridge, right? From Long Island or Queens, right? To the Bronx, right? Early they have a toll, what's that called? Toll block, right? So there will be line. Okay, the car gonna wait in the line to pay the toll fee. There's also queue. Okay. Another example is at a school, right? When guys have lunch time. Okay, you guys also line up, right? And one by one to pick the lunchbox. That is also a line, or you can also understand it as a queue. Okay, so queue is basically, it's very straightforward to understanding, right? When we talk about a queue, it must have front and rear, right? You can also say it's a head or tail. Am I right? But very big difference between stack and queue is. Okay, let's just try to review the stack, right? Louis, I'm gonna ask you this question. What's the special character of a stack?
Is that when you put something in and if you put something out, for example, if you put value 1 in first and then value 2, you have to take out value 2 and then.
What we call that, right? You guys have to remember the term. What do we call this? You are right. This is a correct behavior or correct character of stack. But how we call that in a brief term? Such kind of behavior or such kind of character. How we call that? Do you remember? Victor, do you remember? Hello, Victor?
I don't think so.
You forgot? I think you understand it, but you just don't remember the term. Okay.
I couldn't hear the question. My audio was breaking up.
My question is, okay, Louis explained, right? The special character of a stack is when the things coming in, right? The last one will be out first. Okay, so I said when I explained for the stack, I said one term to describe such kind of character. Do you remember what is that?
First and last out?
Yes, very good. Louis, remember it. First in, last out. Last in, first out. Okay, remember it. Okay, so here we have a similar for the queue. Okay, we have a similar for the queue, but I want to ask you to make a guess, right? What is the similar character for the queue? Julian? It's similar, but think about that, right? Queue, a line up. So the in and out order is what? How the queue or how the line to do in and out? First in. Huh? Victor?
Yes.
Yeah, first in what?
Last out?
But that's a stack, right? But what about the queue, right? When you line up in the school, first in.
First out?
Yeah, first in, first out. Last in, last out. That's queue. Otherwise, when you line up, right? Okay, so keep it in mind, right? No matter what is the programming language it is, when we're talking about data structure, it's all the common, all the same across different languages. When we say stack, remember, first in, last out. When we say queue, remember, first in, first out. Okay? Just like a supermarket, or just like a clinic, where you see the doctor, you need to sign up. They have a waiting list. First in, first serve. right? Same concept. It's Q. Okay, it's Q. So FI, FO, and LI, LO. Okay, so here that's a Q, right? Front, rear. Okay, when it's coming in, right? It's coming what? It's adding or appending to the tail or to the rear, right? Right, because it's last in, right? Last in. And when we come out, right, it's come to the, it is right, do from the front. Okay, do from the front. Okay, first in, first out. So regarding to the function, okay, similar as we having in the stack, okay, we also have empty function, which is return whether the queue is empty or not empty, right? The return type is true or false. We have a size, you're returning the size of the queue. Oh, now I understand. I also need a size property in my queue class. And different from the pop and the push function in the stack. For the queue, we have in queue and queue. Okay? So, I mean, the function name may be a little bit specific, but the meaning is the same. In queue means push something into the queue. Okay, that's the reason why it takes a value as a parameter. Okay, and the value as a parameter. And again, the value here is a literal value. Okay, it's not a node value. Okay, so be careful about that. And the queue is don't have any parameter. Okay, it's basically remove the first element from the queue. Be careful here. When we're talking about the pop function for the stack, it's remove the topmost element, right? Or you can say last element of the stack. But here in the context of queue, when we say queue, when we say remove, okay, it's always remove the first element. Whoever coming first, it will be handled first. Okay, that's different. And last one is the underscore string underscore, right? Okay. So the last function is called a string, right? That is the function which helping us to convert the queue object to literal string. Where the place we're using the string function, okay? We don't have to explicitly to call the string function, okay? Because I see some of you guys are calling the string function like that, right? I have a string function. Somebody may just call, hey, string, right? Yeah, it's a function. I put a function with a parenthesis, right? I run that. It does give me the result, okay? But underscore, right? Just like underscore init, okay? That's a special function which you don't have to call by yourself. Why? Because when you print the myStats object, okay, the machine or the compiler, okay, we're looking for the string function automatically. Okay, so if you have a string function defined, when you call the object, this string function will be called by default. So if I run this, as you can see, the same result I get, right? But if you don't have the string function, look at that, right? If I call the object, you're just getting the memory location of the object. So that's different. Okay. So come back to our slide. Okay, so we understand that's the function we needed for the queue. Now let's look at this, okay? To help you, okay, to help you to understand how the Q behave properly, okay? You know what? Because this the data structure, all this stuff, right, is abstract data structure, right? People may like used to imagine stack at the vertical layout because you can push the item in, right, and it will be on the top of the previous one, right? It will be easy to understand, right? Q a little bit different, right? So here, what I needed to do is I probably will do like that, okay? Q, and I'm gonna have insert, okay, 2 line. Okay, make it a little bit small. Okay, here. Suppose that's a Q. Okay, that's a Q. And then where is the head? Head is here. Okay, let me make a point. Okay, so I make the, oh, you know what, right? Let me be consistent. Okay, here is the front. Okay, here is the front. This is value 1. Okay, that's my Q. This is my head. This is my front. This is my rear. Okay, so first of all, right? Let me remove this. Okay, I don't have any value. Okay, in the Q. This is a Q. Okay, you can understand. Image is a line. So create a new Q. Okay, then when you call the empty function, size function, no, it's not top function. Okay, it's a Q function. Okay, or you know what? I can check like first. Okay, what does it mean? I have a first function, right? I don't call that function because I didn't mention about the function right here. I just ask you what is the first value. Okay, what's the first element? So now when I call the function, what's the value I'm gonna get here? Picture. When I create a new Q, okay, what will be value when I calling this function? Victor.
None. I mean 0.
Empty. Empty is what? Empty is
0.
return, whether it is empty or not.
Oh, true.
Yeah.
True, 0, none.
Very good. Louis. What I'm doing here, Louis. Hello, Louis. Louis, you there? I cannot hear you. Jeffrey. Jeffrey, there?
Yeah.
What I'm doing at the second step. What's the in Q mean?
In Q.
What's the meaning of in Q?
Okay. You add something to a Q.
Very good. So now I add a value 1, right, into my Q. Okay?
Okay.
So what happened is I'm gonna add a value 1 into my Q. Okay, now I call the empty function, size function, and the first element. Tell me what's the result I get?
False.
False?
Yep.
Huh?
Yeah.
1.
False. 1. First is value 1.
Okay. Louis, you there? Louis? Julie? I push value 2, right?
Okay.
Okay? Tell me.
False.
Boss?
2.
2.
1. Value 1.
Okay, continue. Julie.
False.
Okay? Boss?
3.
3.
Value 1.
Value 1. Very good. Okay? Aston. DQ. What happened when I call DQ?
You get rid of the first value.
Which one? Remove which one?
Value 1.
Value 1. Very good. Value 1 will be removed out of from the queue, right? So after that, empty is what?
False.
False. Size. What's the size?
2.
2. What's the first value?
Value 2.
Okay. Victor. DQ.
False.
No, what
One.
happened when I called DQ in this case?
You take down one.
Which one?
Value 2.
Value 2, right? Value 2 is the next. It's the first
It's
element,
false.
right? In the queue.
It's false 1, first value 3.
Jeffrey.
Yeah.
DQ 4.
False.
What happened here?
看我好不好?
Insert value 4, right?
Yep.
Okay,
So
then
it's false 2
false.
and value 3.
2, value 3. Continue, Jeffrey. DQ.
Okay.
Remove who?
Remove value 3.
Okay, remove the first one. Current first one in the queue, right?
Yeah. So it's false 1 and value 4.
Value 4. Okay. Louis. Louis.
Yes.
Okay. Value in queue, value 5. What happened?
False.
Now here, first of all, I need to add a value 4, a value 5, right? So value 5 will be added. 10 actually were added into the rear of the queue, right? Because just like when you line up, someone coming, hey, go back to the end of the line, right? So the guys, they don't come here. I go back here and insert it here. That's called in queue, okay? So tell me, Louis. Empty. Louis.
It will be false. The size will be 2 and then the value.
Yeah. It's false.
Value what? Value 4, right?
Yeah.
Okay. Louis, continue. The queue. Louis.
I think it will be false and the size will be 1 and that
What
will be
happened
5.
when the DQ happening? When I call the DQ function, what
It will
happening?
take out the 4.
Get rid of the 4, right? 4 go out. Okay.
Yeah.
Right. 5 become the first one in the queue now. Okay. So tell me.
It will be false
Yeah.
1 and value 5.
Right. Last one, the queue. Get rid of the
True,
first
0,
one.
and
True, 0, and what?
none.
No. Very good. So, which means everybody know the behavior, right? Or the character of the queue. Okay. So next step, we have to come back to the construction part. We know how the queue behave, right? So now let's think about how we can implement the queue by ourselves. Okay, by ourselves. So in this whole session, I'm helping you to understand what's the basic data structure we commonly use.
so far 我回答的问题都对的，妈妈。
And to learn how to implement those data structure, okay, by ourselves. And in the future class, we're gonna really using those data structure to solving those programming problems. Okay, so that's a step by step. Okay, very important. So now next step is to try to create our queue class similar to the stack class. We're gonna using the node. Okay, we have a node class. We have a queue class, and in the queue class, okay. So let me write it here, right? So you guys are confusion here is I have a properties, okay. I have a head, I have a size, okay, and then I have a functions that's separate, okay. Size, empty, enqueue, dequeue, and underscore and the string. Okay, so that is how my class will look like. Okay, so now let's look at the details. Size and empty is exactly the same as what we have in the stack class. Okay, so we have a size property, right? Self the size property, and we create a function called get size. Okay, that's a function. Okay, just return the size value. We also have a function called is empty, right? Of course, I mean here you can set the size, right? Or get is empty. Okay, it's just there's no difference. It's just the function is different, right? I mean whatever you feel comfortable to you. So is empty function it's returning if the queue is empty or not. How? It's just based on the checking on the value of the size, right? If the size is 0, it means it's empty. But very important, okay? Which means when you make the changes, you include the value into the queue, you include the value out of the queue, you have to remember to change the size value, right? To change the size value, to always to record or maintain the correct count of the item in your queue, okay? So in queue, very important, in queue, okay? Let's take one parameter, which is the new value you're gonna push into the queue, right? If you look at this, right? I mean, you understand, right? I mean, though the direction is different, but we have a queue in this direction. We have a front, we have a rear, and currently, right? Jeffrey, look at my screen, okay? This example, this queue, okay? How many items do I have in this queue right now? Look at here, before. How many elements in the queue right now?
3.
3. Which one is the first one?
A.
Okay.
A, B, C.
When I include a new item, right? It will be pushed, right, to the end of the queue, right? It's just like you are line up, the new customer coming, go to the end of the line. Okay, understand? Same concept here. So after you queue, oh no, not the queue. After you include a new element, E, that's where the queue look like after that changes, right? So the D will be the new tail of the whole line. Okay, you understand, right? So now think about it from the polling perspective. Okay, from the polling perspective, similar to what we're doing in the push function of the stack. Okay, I have this list. Okay, so you realize, right? though we are talking about stack or we're talking about queue, but
It's the first value.
underlyingly, right? Underlyingly, we're still using linked list, right, to implement our stack or our queue. Okay. So here, the first step is create new node. Okay, because I'm passing a value, it's create a new node. Okay, and then I gonna append this new node to the what? To the tail of my list. Suppose that's my list, right? Suppose that's my list, right? To be more consistent with the above example, right? I have A, B, C as the value. Okay. So now I said, hey, let me push D. What happened? First of all, right? I'm gonna create a new node called D. Okay, and then you have to append the new node to the tail. How to append, right? Take out the last node of the list and make the next to the new node. Clear? And
Yes.
don't forget to increase the size by 1. Right? Increase the size by 1. That's it. That's the whole logic how we implement the increase function. Okay. So now let me quickly go to the repo, go to create a new one. Okay, add a new one, set a queue, select languages, right? Select queue, okay. Okay, so that is exactly I wanted to do in assignment. Okay, to implement your own queue class. Okay, queue class. So pay attention to that. Okay, so what we're gonna create first, Louis. What we gonna create first? Hello, Louis, you there? Louis.
Yes, can you hear me?
Yeah, I'm asking you, what is the first I need to create if I wanted to create a queue class?
Class. Yeah, it's great.
What we should create it? I mean, for the stack class, similar for the stack class, right? What we should create it first?
Class node.
Yes, very good.
Self.head. That's listing nodes.
Class node class. Okay. So we have def, right? That has to be right. It's mandatory. Okay. Self. What should I put here? Victor, what should I put for my node class?
Self.head.
Self.head equals to what?
Node.
Hey, wait a second. Is it self.head? I don't think so. Okay, it's a node class. And also I need to pass in value. Right? Remember, we have 2 properties for each node. Remember? We have 2 properties for each node. What are they? Victor, you understand? Remember?
No.
Julian? What are the 2 properties we need to define a node class? Julian?
Self.value equals value and something else equals none.
What's something? What I have for the node?
And self.next equals none.
Yeah, right? For each node, okay, we need to know the value. We also need to know what? Know the next reference, okay? So, yeah, I just realized I didn't turn on the video. Okay. Jeffrey,
Yes.
how many property do I have in the node class?
You have two,
Okay, what are they?
self and value.
Self is not a property.
Init and value.
Init is not a property.
Okay, next and value.
Now you're correct. Okay, I hope you remember that. Okay.
Yeah.
Whatever followed by the self, after the self is a property. Whatever defined in the init function and after the self dot, that's the property of the class. Okay. Now create a queue. Okay. F init same, right? We have to write in the init function first. Okay. We have self. That's a mandatory first one. I will put for all the functions inside the class. Okay. Now Victor, this turn we need a head equals to what?
None.
Okay, no. Very good. When we talking about stack, if you remember, when we talking about stack, we said what? Oh, we need having a dummy head. Okay, we need to have a dummy head. The reason why we need to have a dummy head is because when we push the value into the stack, because we have to do the behavior first in, last out, which means I have to holding the reference to the last one always. Okay, so in this case, when we are maintaining the list, what we're doing, we insert the new node always what? At the front of the list, right? We always insert the new value at the position which is after the head. Okay, so in order to support that, we need to have a dummy node to hold in that position. Okay, but in the case of the queue, I don't need. Okay, because it's first in, first out. Okay, so I'm able to using a head pointer directly to point into the first one. And whenever there's a new value coming, it's added to the end of the list. Okay, very important. So here I have a head, but I don't need a dummy head or dummy node. Okay, and what else? Victor, what else property do we need here for a queue? Think about that.
Self and next.
No, we don't need next. Next is on the node level. Node need to know who is my next, but queue don't need. Okay, queue need to know who is my head. That's enough. But there's another property we need to remember. We need to change every time when we change the queue. What's the property name? Aston, do you remember? We're already talking about
Size?
size. Okay. Size is another property we need to remember. Okay, Victor. Clear? Okay. So let's first implement the easy one. Okay. F is size. Okay. No, don't forget the self. Okay. That's a simple function. We just need to return self.size. Same thing. Is empty. Okay. Self. Okay. Return. Louis, what should I return here?
Oh no.
You don't know. You supposed to have completed your calling for stack, right? How can you don't know? How to check if the queue is empty or not? Right, Jeffrey?
Yeah.
What What should I write in here?
I think you should write return return false.
Return false. Why is that return false?
Okay, well, I think you should return true because the size is 0.
That just make me doubting if you're writing your code by yourself. Okay, Julian. What should I write in here?
Return empty.
Return empty. What do you mean return empty?
All right.
As in the
Current self dot size double equal sign 0.
That's my logic. That's my logic of the function to check if the queue is empty or not. Louis and Jeffrey. Right? In queue. Okay? We take the value because that's a new value we're going to insert it. What's the first thing we're going to do? We explain, right? What's the first we're going to do? Aston. Aston? Aston, you there? Okay, Victor, try it. Victor?
I don't know this one.
You don't know this one, but we just explained this one, right? We explained here. I already explained to you what's the step we should insert or include a new value, right? Do you want to try? How we write the include function? Okay, that's a step. I already told you, right? That's a step. The new value coming, what's the first thing that to do? Create a new node, right?
Okay.
What's the next step? Append the new node to the tail of the queue, right?
Yeah.
The tail of the queue to the tail of the list. Find out the last node of the list and what? Set the next of the last node to the new node, right? And then what? Last one is increase the size by 1. That's the logic in your function. So now I need you to write the code. How?
Okay.
What's the first thing? Julian? Create a new node, right? How we create a new node? You create a new variable, right? Holding the new node.
Oh.
Right? That's a new node. What's the next step? Victor, what am I supposed to do next?
Self.head equals to 1.
Self.head equals to 1. Why self.head equals to 1? I didn't get that. Aston, you there?
Yeah.
What's the next step? I have already created a new node. Then?
To append a new.
Okay, append a new node to whom?
To the queue.
To the queue. Okay, so suppose, okay, let me show you one by one, right? So that is my queue, right? Again, when we say queue, underlyingly it's a list, right? We have a head and we are linking node by node reference list. So now I wanted to input a new value. I create a new node. Okay, I create a new node here. Okay, so suppose that's my new node. So what I should do? Next, what should I do next? I want to append. How can I append?
Make the current head.next,
Hmm.
and
You
then
still
make
remember? Go ahead. Sorry.
make the new node the head.
But when we say append the new node, right? We append to the end of the list, right? I'm not changing the head. Am I right?
Oh.
I'm not changing the head. I'm just append the node to the tail of the list. Okay. So in order to be able to append, what do you think we should first do? Aston.
Increase the size.
No, increase size is after that. But in order to be able to append the new node to the tail of the list, what should we first do? Just to remember how we append item in a list, in a linked list.
We make the new node the next value of the last one.
Very good. I need to make the next of the last one to be the new node, right? But in order to do that, I have to know who is my last node. Am I right? Right now, I only who is my head because I have a head property. But how can I know who is my last node? How?
And loop it.
Loop it, right? Remember, loop it. Okay? In a linked list, we loop it. Okay? So, in order to loop, we need to create a temp variable, right? We set a current. We make the current equals to self.head. Okay? So now we are while loop it. While, what I need to find? I need to find the last node. So the while loop should be stop, okay, when I find the last node, right? So what condition should I put here? Aston, what condition should I put for the while here?
While current.next.
While current next. Okay. If I say like that, while current next, what does it mean?
So while a node has a next value, it will keep looping it.
Very good. Okay, that's exactly the logic checking here. If you set a while something, okay, I mean, because we said a compare condition can be different type, right? The most easy understand way is like while a equals to 1. You just compare a if the a equals to 1, right? That's the most simple one. But here, if you put a while something, is checking if the something is none or not, right? The while is keep looping if it is not none. And when it's become none, it's gonna stop. When it become none, when current next is none, only when the current pointing to the last one, correct? So inside my while loop, I just need to make sure it's looping to my next. Understand that? Right? So after I coming out of the while, basically the current is my last node. So set the next of my last node pointing to the new node. And don't forget what? Self.size. That's it. Any question? Any question here? Okay, so if no more question, let's take a look at the DQ. Okay, this is a DQ function. It's basically remove the first item from the list or from the queue. Okay, so that is the before. I have 4 items in the queue from the first to the last, A, B, C. Okay, and then I call the queue. I basically remove the first item from my queue, and my original earliest second item will be pushed forward, become the first one. Okay, so if I take a look at this list, okay, right, I make changes, right? A, B, C, right? D also, okay? That's my queue before. Okay, so when I say the queue, remove the first node. It's a list. How can we remove the first node? Aston, how can we remove the first node from the list? Aston?
You make self.head.next the new head.
Okay, very good. When we say remove the first item from the list, what we do is let's make the head pointing to the next one. Okay. So then when I say head is going to be starting from the early second one. Right. This basically remove the first one out of the list. Okay. And of course, the last step is always decrease size by 1. Okay, but there is a scenario we have to check. Okay, what scenario? Right. Remember when we do the pop in the stack, right? What happened if the queue itself is empty? Okay, the queue itself is empty. You don't need to do anything, right? So the queue, perhaps we first need to check if the queue is empty, right? Louis, how can I
我是
check?
上到9点，45分。
Louis, how can I check if the queue is empty? Louis,
Yes.
how can we check the queue if the queue is empty or not? Huh? How?
Maybe you can use it if like the stack is empty.
You have is empty function already, right? It's called function. Okay? Self dot is empty function. Okay? So once it's empty, raise an exception. Okay, that's a check the exception, right? It's called hey, we want the queue, but it's an empty queue. Okay, so after we handle this case, now we need to ready the Q1. Okay, so remember that the queue function, right, is remove the item from the queue, and it should also return the value of the removed one. So we need the value. We know the value is coming from the node, right? So we need to create a temporary variable to holding the first item. Okay, how we create that, right? We can say first equals to, because right now the self.head is pointing to the first node, right? So I create a variable to holding that or to point to it, right? We cannot lose it, okay? And after that, I do self.head dot equals to self.head. Right, what I'm doing here, I change my head and move to the next one. Right, namely, I remove the first one out of my list. Okay, so I'm done that. Okay, so make sure self.size. Okay, self.size decrease by 1, and then you should return the value of the removal. Right, so I should add a 1 here. Return the value of the. Okay, so that is how we implement the Q function. Any question? Any question? Okay, so if no more question, let me see. Yeah, same thing. We should this one Q. Okay. We should also implement str function. Okay, so now let me quickly implement the last function I wanted is str, which I can print out the Q function directly, not Q function, Q object directly. Okay, I create an outer string variable to holding the whole string, right? And I have a current to holding the self.head. Okay, now I need a while loop. Okay, because I wanted to concatenate the value for every node, so which means I have to loop the whole list. Okay, while current. So this time, I just looping to the end. Okay, looping to the end. Okay, so I just checking the if the current is noun or not noun. Okay, so if it's not noun, what I do is out of string, we need to pass in the current start value and what pass this delimiter or connect whatever, right? And make sure you do. Okay, here. Be careful about here is here we're checking the current up next, but here we're checking the current. What's the difference? Aston, can you tell me what's the difference here? This way we're checking the current up next, but here we're checking the current. What's the difference?
For the first one, you're looking for the last node, and for the second one, you're just checking every node.
Yes, correct. Okay. The first one where I'm checking the current up next is I wanted to the while loop stop at the last node. Okay. But here, if I'm checking the current without next, which means I'm gonna also loop in the last node, right? Until my current equals to the none. Okay, that's a difference. So here, I got the concatenate string. When I return the concatenate string, make sure you put that -3. What does it mean? Because I don't need to print the last arrow. Okay, the last arrow. So now, what happened here is have give you undefined name self. Oh, because I'm missing the self in the parameter. Okay. Okay. So let's try it out. Okay. I have a node class. I have a Q class, right? So I have. I can create my Q equals Q. Okay. Let's try to print out something. Okay, I'm printing out Q. Right now I have nothing, right? Print out is empty, right? Because there's no node in the queue. Okay, so if I print out my queue dot size, okay, I'm gonna call the get size function. Okay, And again, I said, right, you can call the property as well as you can call the function itself, right? Get the size, return the size. My Q, so it should need to give me 0 or it's give me 0. It's a vacuum. Okay, anyway, I can also print out my Q dot what is empty. Okay, for this one, give me. Okay, now I'm gonna enqueue the value into Q, right? So my Q dot enqueue the value A, right? Let me put several things, right? A, B, C. Now, if I print out my Q, what am I gonna get? Jeffrey, what I will get here?
What error do you get in the terminal?
You think I'm gonna get the error?
Wait, no, I think you said error. I think that's.
What seems I'm gonna get in the console?
Oh, I guess you're gonna get A, B, C.
Okay.
Actually, no, it's CBA because it's CB.
Give me an error. Why? Anybody know why it's giving me error? Aston?
Because you didn't connect the values with next.
Okay, look at here. Okay. The error is happening in line number 53. Okay, line number 53, I'm trying to include a into my queue. And then it should be supposed to call in this enqueue function, right? And it said line number 22, in the enqueue function, that's a place through the arrow. Why? Aston, can you say that again? What do you say?
Because there's no next value.
Why?
Because you didn't connect it?
Because it's connected. Look at the error messages, right? It said non-type object has no attribute next. Oh, I'm calling the current on next. So it means current is a none. Why current is none? Because I make the current equal to self.head, right? But remember, that's the first time I enqueue. The queue is empty, right? So when I make the current equal to self.head, current is none. Okay? So when you said none.next, it's basically giving you this error. Question, you understand that?
Yeah, so you need to establish a head for the queue.
Oh, how can I fix that?
You just make value A the head.
But I need to have some condition, right? When in the enqueue function, you need to add one condition check. What condition check we should add here? Aston? We have to take care of this edge case. Okay, what's the edge case? The edge case is if the queue is empty right now, I don't need this logic, right? What I need, as you just said, is I just need to set my header to the new value. So I have to put my logic like that. If self dot is empty, okay, what I need to do is self header to know the value for the new node, right? If it's not empty, else, okay, then I'm gonna do the looping, find out the last node, and then what? Append the new node to the last node, right? But again, look at here. Be very careful about the indentation, okay? This increasing the size by 1 is outside the if else, right? So which means no matter which case, right, the size should be always increased by 1. Aston, you get that?
Yeah.
Okay, so now let's run this. It's working. Okay, so in the coding perspective, there are lots of edge cases you have to think about that, right? Is it possible, empathy? Is it possible, you have to handle this edge case. Okay, for example, like when you create a username password, right? You have to think about some edge case like, hey, if the username password is empty, right? When a user just put a space and log in, or is it possible like, hey, the name or the value didn't meet the requirement, right? The password maybe didn't meet the how to say standard for the password, because sometimes password need require some special character. So such kind of edge cases you have to be careful in your coding. Okay. Okay. So now this continues as my q.deq, which we have in q3 values, right? So now with the q, again, q is a function without any parameter. Okay. And then my q.deq. Okay, I deq 2 times. Okay, Victor. Now, if I said print my q, what I get?
It adds under the Q thingy.
That's my code. In Q3 values, Q 2 times, and then print out the Q, what I get?
On my Q.
What will be left in the Q?
None.
Are you sure? You're in Q3 values. At that moment.
Oh, then it would be BC.
What? You sure what?
BC, two more values.
How many values? First answer my question. How many values left in the Q?
3.
3? We are talking about here.
No, but there's 3 values in total, but after would be 2.
Okay. I added 3 values, right? I print out the Q. It print out the Q, ABC. Now I said the Q, and print out the Q again. So now I'm asking you, what can I print out? Victor? Student,
Huh?
what will I be print out? What am I going to say? What should I do say? Okay, Jeffrey, what's the last print out? Jeffrey, still there? Okay, anyway, I cannot help you guys, right? Aston, what's the last print out?
Value C.
Value C. Okay. Value C. Do we understand that? Victor, Judy.
Yeah.
Why is value C? Because the Q twice, right? If I print out my Q in the middle again, I run this. I'm gonna add the 3 values.
It removes the first value.
Yeah, I DQ 1 time, DQ the A, so it's remain as BC left. I DQ 1 time, it have the C only. And what happened if I DQ another times? I'm print out my Q, What am I getting? None. Q is empty, right? Q is empty. You can print out, hey, here the Q is empty. Guys, any more questions? Okay, if no more questions, that's it. Thank you, everyone. Okay. I'm gonna publish the assignment video tonight. Okay. Take care. Have a good night. Bye-bye.